Ladies and gentlemen, welcome to this presentation on Lending Club and its potential for investors seeking higher financial returns. In this insightful overview, we will explore how Lending Club presents an opportunity to outperform traditional investment options, the challenges investors face, and the strategies to address them. As a consultant, my role was to assist an investment company in selecting the best loans to invest in, utilizing data analysis, predictive modeling, and simulation techniques. Lending Club's opportunity and risks. Lending Club is known for offering investors a chance to achieve impressive financial returns, especially when compared to alternatives like savings accounts. The company's advertisements promise potential returns ranging from 5% to 7%. However, it's essential to recognize that investing in Lending Club comes with the risk that borrowers might default on their loans. Evaluating loan quality becomes crucial for investors, as this impacts their decision-making and exposure to risks. An investment company is planning to allocate $10 million to invest in loans through Lending Club. I have been hired as a consultant to assist the company in selecting loans for investment. The loan data is sourced from Lending Club website. The dataset covers loan data specifically from the year 2015 and focuses on 36-month loans related to credit card debt. The dataset comprises 7,151 rows with 16 variables, providing a comprehensive dataset for analysis and decision-making. Data understanding and pre-processing. To assist the investment company, I began by understanding and preparing the dataset. I have dropped unwanted features, handled missing values, treated duplicates and outliers, and converted categorical variables using techniques like one-hot encoding. The result was a dataset of 7,148 rows and 11 columns, providing a solid foundation for analysis. After reviewing the given data, it was determined that several columns are irrelevant for the purpose. One column contained missing values. Furthermore, outliers were identified in 8 columns. 5 categorical variables were recognized. These issues were addressed and the processed data was used to construct a predictive model. The model's goal is to support the investment company in making informed decisions about which loans to invest in. A histogram illustrating the distribution of interest rate is shown here. A scatterplot illustrating the relationship between annual income and interest rate is shown here. A scatterplot illustrating relationship between loan amount and total payment grouped by loan status is shown here. Predictive analytics. Logistic regression. My journey into predictive analytics involved building models to classify loans as good or bad. One approach was through a logistic regression model. This model evaluated the likelihood of loans being classified correctly and yielded valuable insights into true positives, true negatives, and the area under the curve, AUC. An AUC of 0.6954 showcased the model's ability to distinguish between the two classes, informing investors about the potential risks. Upon applying the logistic regression model to the validation set, following results were obtained. Classification tree model. Next, I have utilized a classification tree model for loan assessment. This model highlighted the variable, int_rate, as the most influential in the decision-making process. The AUC of 0.6968 reflected the model's improved separation between classes, demonstrating its capacity to categorize loans effectively. Neural network model. The neural network model also played a crucial role in loan assessment. With a respectable AUC of 0.6868, this model offered accurate categorization insights, enhancing lenders' informed decision-making process. Improvements to predictive models. Seeking improvement, I have turned to boosting and bagging techniques. Implementing these strategies enhanced the initial AUC of 0.70 to an impressive 0.745, representing a significant 6.43% improvement in predictive capabilities. Bagging, another ensemble technique, involves building multiple models on different subsets of the training data. I have chosen the random forest algorithm as it builds multiple decision trees and aggregates their predictions. After implementing boosting and bagging techniques, initial AUC of 0.70 increased to 0.745, which corresponds to a notable 6.43% improvement, indicating the effectiveness of the applied techniques in enhancing the predictive capabilities of the model. Prediction of losses. Considering the prediction of loan losses, we focused solely on loans with the charged-off status. Creating a new column, loss, allowed us to calculate the difference between loan amounts and total payments. Our linear regression tree, and neural network models were constructed to predict potential losses, with results demonstrating the accuracy of our predictive models. I have constructed a linear regression model. The dependent variable was the loss column, while all other variables except loan_AMNT, total_PYMNT, and loan_status served as explanatory factors. Upon evaluating the model's performance on the validation data, I have obtained the following metrics. Adjusted R-squared, 0.8265. Root mean squared error, RMS error, 2168. Upon constructing the regression tree model, I have discovered that the variable, installment, emerged as the most significant factor in influencing the predictions. By applying the regression tree model to the validation data, I have computed RMS error 2204, which provides insight into the average magnitude of differences between the predicted and actual loan loss values. Upon crafting and training the neural network model, I have rigorously assessed its predictive capabilities on the validation data. My evaluation yielded a RMS error value of 2110, which offers a comprehensive perspective on the average magnitude of differences between the model's predicted loan loss values and the actual outcomes. In the pursuit of refining our loan loss prediction model, I selected the bagging model, which demonstrated remarkable progress. The RMS error on the validation data was significantly reduced, achieving a value of 1945. The bagging model, post-improvement, can better assist lenders in predicting loan losses and making informed risk management decisions. Simulation and optimization models for investors. Understanding a loan portfolio's risk and return potential is vital. Simulation and optimization models provide invaluable insights for informed decision-making. Through cluster analysis, we categorized loans into groups, facilitating the estimation of portfolio performance. Running the K-means clustering tool and assessing normalized coordinates led us to 5 distinct clusters, each representing unique loan characteristics. Cluster analysis. To run the K-means clustering tool in ASP with normalized data and K equals 5 clusters. I had uploaded my data file on the ASP website and selected the option to normalize the data. This scaling process transformed each variable's values to a range between 0 and 1, enabling fair comparisons. Then I chose to run the K-means clustering tool and specified 5 clusters. The algorithm grouped cases into clusters based on their similarities in normalized variable values. Thereafter, I have examined the clustering results and noted the normalized coordinates, average values of variables, for each cluster. Visualized the clusters and their centroids graphically. The normalized coordinates for a solution with 5 clusters and 7 variables. The table indicates 5 clusters and 7 variables. Interpretation of cluster 1 and 2 is displayed. Interpretation of cluster 3, 4 and 5 is as shown here. Inter-cluster distances is shown here. Inter-cluster distances analysis is shown here. Simulation model. My simulation model estimated an expected total return of approximately $245,000 for a $10 million investment distribution after 1 year. This value accounted for interest rate, default rate, and loss fraction variations across clusters. Furthermore, I have explored the probability of exceeding $500,000 in returns, revealing an approximate chance of 0.56%. Optimization model. Lastly, I have constructed an optimization model to maximize the Sharpe ratio by distributing the $10 million funds across clusters. This model provided a compelling expected total return of $275,000 after 1 year. Additionally, the simulation-based analysis indicated a 21.65% likelihood of surpassing $1 million in returns, offering investors a solid understanding of the risk-return profile. In conclusion, Lending Club presents a promising avenue for investors seeking higher financial returns, although it's essential to navigate the associated risks. My comprehensive analysis, predictive models, and simulation techniques offer a strategic framework for investors to make informed decisions. By utilizing these insights, investors can tailor their loan portfolios to optimize returns while managing potential risks. Thank you for joining me on this journey through Lending Club's investment landscape.